So in algebra, you learn how to find a composition of two functions, f of x and g of x, which was written symbolically as f of g of x. If we have that f of x is equal to x to the power of 7 and g of x is equal to 3 times x squared plus 5, then you know that that f of g of x is going to be equal to parentheses 3x squared plus 5 to the power of 7. Similarly, you have that if f of x is sine of x and g of x is x cubed, then you have that f of g of x is sine of x cubed. Moreover, you have that f of x is equal to x cubed and g of x is equal to cosine of x, then you know that f of g of x is going to be cosine of x cubed, which we can write as this. Okay, so what we can say that it's a plane function are functions that look like this. Composite functions are something that looks like this. Okay, so in calculus, when we need to find the derivative of a composition of functions, we are going to use what we call the chain rule. Okay, so in problems such as this one, which you learned to differentiate earlier this week, the chain rule can be written this way. If y is equal to parentheses u to the power of n, then we know that the derivative is going to be equal to n times u to the power of n minus 1 du dx. So it's pretty similar to the power rule. The new part that you have is this du dx. The du dx means that you have basically another term multiplying by the derivative of the inside quantity. The inside of what? The inside of the big function. Okay, so our calculus book writes the chain rule the following way. We have d dx of f of g of x is going to be equal to f prime of g of x, close it, times g prime of x. Please note that g of x is the one that it's inside f. Okay, so that's why it's here and here. Okay, so now let's do it in an example, and you'll see that it doesn't look as intimidating as the actual formula. If I ask you to find the derivative and do not leave negative exponents or complex fractions in your answers, what are you going to do here? Okay, so here you see that you have this power of 5. Okay, therefore we're going to do kind of like the power rule. You are going to have 5 times 4x cubed plus 3x minus 2, close it. 5 minus 1 is going to be 4 times the derivative of the inside. What is the inside? All of this chunk. Okay, so what's the derivative of the inside? It's going to be 12x squared plus 3. Okay, and you are going to have that this is your situation. Okay, since we don't have any negative exponents and we don't have any complex fractions, we can stop here. Okay, so let's move on to another example that we have here at the bottom of your page. Okay, so you have y equals x to the power of 4 plus 2 and everything to the power of 2/3. So what are you going to do here? Well, kind of like the power rule, so you have 2 over 3 times x power 4 plus 2. Then 2 over 3 minus 1, it's negative 1/3, times the derivative of the inside, which you know that it's 4x to the power of 3. Okay, so here we have an issue because this is negative and we have that that's a fraction. Okay, so what are you going to do here? We will want to simplify. Okay, if you want to simplify the situation, you know that this is going to be equal to 8, y8 2 times 4. Okay, so x cubed. Then you have the 3 that goes down, and I'm going to put this one at the bottom using properties of exponents. Okay, moreover, you want to make sure that this guy is not a fraction, so you want it as a radical. Okay, so you have the 3, and this is going to be the cube root of x power 4 plus 2. Okay, and that's pretty much it for this one. That's as much as you can do. For the next one that we have over here, what do you have? Well, this one you have two options, and the easiest option here to use the chain rule is to do this. Because of course you can do the quotient rule, but that's too much, okay? You can just use your properties of exponents and pull the negative 2 here, okay? Now we're going to take the derivative, okay, using the chain rule. So you're going to have negative 2 times negative 7 is going to be positive 14, parentheses, and you have 2x minus 3 to the power of negative 3 times 2, okay? So once you have this, again, I need to simplify this equation, so you know that this is going to be 28 divided by 2x minus 3 to the power of 3, and this is as good as it gets. Now for this one that we have over here, what's the easiest approach? So the easiest approach for this one, again, is to pull the bottom part top, okay, using properties of exponents. This is going to be negative 1/3. Okay, once you do that, you're like, okay, still I have a power rule, right? So we have a power rule and a chain rule in this situation. How? Okay, this is going to be your f of x, this is going to be your g of x, okay? So let's do the chain rule and power rule together, okay? So first, the first one times the derivative of the second one. What's the derivative of only this piece? It's going to be negative 1/3 times x squared plus 2 minus 1. It's going to be negative 4/3 times 2x. Okay, so we finish the first part, plus the second piece, okay, times the derivative of the first piece, which you know that it's 5. Okay, obviously here we need to simplify, okay? So here I'm going to simplify, okay? So g prime of x is going to be equal to, and you know that it's going to be negative, that it's going to be 10, okay? X, and then you have a 3 here, then you have that this equation is going to be cube root, okay, x squared plus 2, and this is going to be to the power of 4, okay, and you have this piece, okay? Now this one over here, you know that it's going to be plus, and it's only going to be 5 on top, and then again you have the cube root of x squared plus 2, okay, and that's pretty much what you have for this equation. Okay, that's as good as it gets. Okay, now we will use the trig formulas the way that they are written on your formula sheet. Okay, and now you're going to understand why they are in this way in your formula sheet. You have that the derivative with respect to x of sine of u, it's going to be cosine of u du dx, having here the chain rule. Okay, same here, 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 and here. So you know that you need to look at what you have inside, basically the parentheses, or what we call the what was it, the index or whatever inside. Okay, you need to take the derivative of that. Okay, how? Okay, let's do these examples. With trig functions such as e, f, g, the chain rule means that your derivative will be found by the derivative of the trig function. Okay, so, or the derivative of the angle, okay, whatever you have here. Okay, so you have y equals cosine of 3x. So what's going to be that? First you do the derivative of cosine, which you know that it's negative sine, okay, and you know that it's 3x, okay, because this is your argument, so the argument stays the same. Now you need to multiply times the derivative of the argument. The derivative of the argument is, in this case, is 3. Okay, so if you want to rewrite the situation, it would be equal to negative 3 sine of 3x. Okay, so that would be your y prime. Okay, if you want to make it pretty. Now this one over here, what you are going to do, you know that sine, the derivative of sine is cosine. The argument stays the same, 5x squared, times the derivative of the argument, which is going to be 10x. Please note that this 10x is outside the argument of cosine, so it's not part of the angle. Okay, so you can pull it like here. So you have f prime of x is going to be equal to 10x cosine of 5x. Now, over here you are like, oh no, cosecant, okay? Cosecant of 7x to the power of 5. So what are you going to do? You know that the cosecant is negative cosecant cotangent, okay? So you just know that, okay? Remember, the argument stays the same. You do not change the argument, okay? So you have cotangent of 7x power 5, okay? And then you need to multiply this times the derivative of the inside, which is going to be what? 35, and I'm running out of space here, x to the power of 4, okay? So let me rewrite it here. Y prime is going to be equal to negative 35x to the power of 4 cosecant of 7x power 5 times cotangent. Let me just erase this one, and I'm going to put it strategically here, cotangent of 7x power 5, okay?